In preparation for the Kirchhoff's voltage law and Kirchhoff's current law lab, we need to set up the power supply. We're going to set it, first of all, we're going to set the 6-volt side to 6 volts. It can actually go a little bit higher than 6 volts, but we're going to leave it right at 6 plus or minus a couple hundredths. And once we get that one set, then we're going to go to the 20-volt side, and we're also going to adjust it to be about 6 volts. Because the circuit needs 2 different power supplies. Now we could probably get away with using the same power supply twice, but we're going to not do that. We're also going to plug a red cable into the plus 6 volts, a black cable into the common, and another red cable into the plus 20 volts. Then we're going to connect this to our circuit. So the circuit is shown right here. So I've already wired up this circuit according to the circuit diagram in the lab handout. And I'm going to attach the first 6-volt source here on the left. It's always good practice to turn the power supply off when you're connecting it. So I'm going to attach the first 6-volt source here on the left. I'm going to attach the second 6-volt source here on the right. And then there's just a wire down here on the bottom right-hand corner there that I can use to attach the ground. Now, one thing that I didn't mention in the video on breadboards is that sometimes in certain breadboards, especially older ones, you'll find that this blue stripe and the red stripe that I was so proud of, they actually don't connect all the way across. And that happened on this breadboard. I had to put a jumper here to connect the left half of the blue stripe to the right half of the blue stripe. And so if you ever find that you're having some trouble with your circuit, maybe check that. Of course, once you've checked it once for your breadboard, you won't need to check it anymore. So notice here that I've got all of these 1, 2, 3, 4, 5, 6 resistors that are each 82 ohms. I have a diode in the middle here. I have the jumper wire here. I have 2 different power supplies and a ground connection. And then there's this wire right here, which you may not have been able to see, but that wire is connecting the bottom of the LED down to the ground strip. So that's going to provide the full circuit. So if I go ahead and turn on the power supply, you can see that the LED is glowing very nicely. If I were to turn down either of the voltages, and I'll go ahead and turn down the left-hand voltage right now, if I were to turn down either voltage substantially, you'll find that the LED will start to dim and it'll eventually go off. Because it turns out that it requires both of the voltage sources. This circuit is designed so that only if both voltage sources are delivering the full 6 volts, only then do we get the correct current flowing through the LED. Remember that we need nominally about 20 milliamps to flow through the LED, but we need to measure that in the last step of the lab. And so I'm gonna pull my multimeter up here next to the breadboard. And just to clarify here, let me zoom out. I have the multimeter set so that the red terminal is going into the milliamps and the black terminal is going into the common. And then I'm going to take the 2 terminals here, the 2 leads from the multimeter. And what I need to do is I need to find out how much current is flowing through the LED. I can actually use Ohm's law to measure the resistance. I can measure the resistance of each of these resistors and then use Ohm's law to find that current. But Ohm's law doesn't apply to an LED. So what I'm going to do is I'm going to pull this wire out here. And of course, as I pull the wire out, the LED will go out because now there's no current flowing through it. And then I'm going to hold this one on here. And I'm going to touch the LED. The LED will light up again. Oh, and I've put the leads on backwards. You should always have the bottom lead as the destination, and the black lead is the destination, and the red lead is the source. You can see that we have about 16.9, 16.8 milliamps flowing through this LED. And so that is, we can get 20 milliamps going through the LED, but the measurement that we just showed shows that it's about 16.8 or 16.9 milliamps flowing through that LED, and that will give us the result that we're looking for. So that's the measurement that you need to make at the end. You'll also need to pull each of the individual resistors out of the circuit. And again, I'll turn the power supply off to do that. I need to switch this over to the right-hand terminal. I need to pull this one from amps up to ohms. I'll put it on the 200 ohm setting because each of these resistors is about 82 ohms. And I have to pull the resistors out because if you try to measure them in the circuit, then you're going to get the wrong reading. It will not read correctly. So when I measure this one here, I'm getting about 77.8 ohms. Well, it says that it's 82, but it's 82 plus or minus about 5%. And so we're taking advantage of that plus or minus 5% here in this result. So that will give you an idea of the resistance. You can then use Ohm's law, and then you can use the results for those voltages and currents to verify Kirchhoff's voltage law and Kirchhoff's current law.